Extended reality is a kind of an umbrella term encompassing several different technologies. If we start with the physical reality and we add some layers of simple static information, then we get augmented reality. If we complicate a little bit the type of information that is layered on top of the physical environment and we show 3D objects that can interact with the user, then we have mixed reality. If, on the other hand, we are completely in a virtual environment and we have no visual contact with the physical reality, then we talk about virtual reality. Therefore, in augmented reality, physical reality is predominant, and we just have a few simple static information augmenting the environment and giving maybe useful information. Mixed reality instead, the physical environment is enriched by complex 3D interactive objects, which the user can interact with and maybe learn how to use something that is not even present in the physical space. And in virtual reality, everything is digital, everything is virtual. There is no visual contact with the physical reality, and everything we see is purely digital. It's not easy to define virtual reality with a unique and consistent definition. If you look on the web for virtual reality definitions, you will find tons of them, each one differing for something. But if you focus on the important words of the definition, then you will find that these 8 keywords are recurring in every definition. And these keywords are environment, computer, senses, user, simulation, interaction, immersion, and presence. And if we rearrange a little bit these keywords, we can define virtual reality as a communication between two peers, a human user which perceives a digital environment simulated on a computer by his senses, this environment being characterized by 3 important features: immersion, interaction, and presence. Immersion and interaction are the 2 most important technical aspects of any virtual reality experience. Immersion is the physical feeling of being in a virtual space at a sensorial level, and this happens through technological interfaces, visors, haptic interfaces, headphones, and so on. So it gives an impression of how the user is able to perceive the virtual environment as if it was real. On the other hand, the interaction is the ability of users of modifying the environment, so they are not simple spectators, passive, but they have an active role in the experience. They can modify the experience, they can perform actions, and they can receive a feedback to their action. So this gives a measure of how the simulation is realistic. Presence is the main objective of any virtual reality experience, as literature suggests that virtual experiences providing a high level of presence have a better impact in the efficacy of learning and the long-term retention of the knowledge which is gathered during the virtual reality experience. And in order to achieve high level of presence, we can provide high level of immersion and high levels of interaction. But this alone is not enough, because as presence is defined as the mental feeling of being in a virtual space and is related to how much the user is involved in the experience, the user must be kept into account, and users themselves must be active in this, and they have to willingly suspend their disbelief and accept that what they are experiencing, even if they know it's not real, can be treated as it was. In the end, the user must be involved in the simulation through a high sense of presence, and this means that we have to build virtual environments that can be highly interactive and give users freedom to do whatever they think they might do in that environment, and high levels of immersion, meaning that we have to feed back to the user information of high quality on the visual channel, so high quality images, on the auditory channel, high quality sounds, and so on, also on the tactile channel and across all the sensorial channels. We probably have now a better idea of what virtual reality is, but it's also important to understand what virtual reality is not, or what is barely virtual reality. As a matter of fact, 360 videos that often are called kinematic VR and are considered as a type of VR cannot be considered as proper VR because the interaction is really limited. The only interaction that you have is just looking around, but you cannot move objects, you cannot interact with other people. Therefore, this experience cannot be defined properly virtual reality. In order to have a proper interactive virtual reality, we must use environments that are built using real-time 3D graphics. Still, even if we have the maximum of flexibility and interactivity, we might not have the best visual quality like we have in movies. In this case, for instance, you see on the right a performance from Dire Straits in the 80s, shot with a standard video camera, and on the left we have a virtual reconstruction made in 3D of the same performance. As you can see, the visual appearance, although good, it's blocky, it's not completely realistic. So we might perceive something strange when navigating that environment. But that is the key. We can navigate that environment. We can walk across the audience. We can go on the stage. We can see the performance from a closer distance. Something that we cannot do in a movie. Although, of course, video images have commonly a better video quality. So if we want to use virtual reality in performing arts, we must carefully define and understand how we can realize virtual performance. There are two types of virtual characters that can populate a virtual environment. The first type is the avatar. The avatar is a virtual character, a virtual human, which is basically the digital alter ego of a human user. So it's basically an animated 3D model that is driven directly by the action of a real person and replicates instant by instant all the movements that the real person does. On the other hand, we have agents. Agents are virtual humans that are guided by an artificial intelligence. Whether it is a complex AI or a simple AI, there's no human involved. Embodied agents are virtual humans that are autonomous in the virtual environment. So in order to have our avatar in a virtual scenario, we start from the real person, for instance, myself. I have to use some kind of motion capture mechanism able to understand my movements and my actions. These are applied onto a digital avatar of myself, a virtual human, which is then embedded inside the virtual scenario and can be immersively visualized by possibly other people sharing the same virtual scenario. In the case of agents, instead, we have some artificial intelligence which is able to use some kind of virtual perception in order to gather information about the virtual scenario where they are embedded in. They have to elaborate the information that they acquire by means of their virtual perceptual system, and these guide the behavior of the agents. The behavior of the agents is then transformed into actions, and these actions lead at the same time to a visual feedback by means of immersive visualizing the embodied agent, but also to an auditory feedback. If we give to the system the capabilities of speech synthesis, the behavior can decide that the agent can speak and elaborates a text that the agent will tell, and then the mechanism of speech synthesis will be able to let us perceive what the agent is saying in that particular moment. At least this happens in theory. Sometimes things are a bit simplified, so embodied agents are moved and behave by means of a simple script. They execute the scripted actions, so there's nothing fancy involved. No artificial intelligence, no behavioral modeling. It's just the agent executing orders that have been scripted before the actual experience. So what do we need in terms of technology? We might need a motion capture system if we want to animate users' avatars. And these motion capture systems range from very fancy and expensive devices like the ones used in high-level production in the world of cinema, but also low-level platform used, for instance, for video games. One of the most important virtual reality device, which is the Oculus Quest 3, is able to detect the motion of our hands and to interpret our actions. If we need a more complete system, we may spend a little bit and get maybe a Sony Mocopi or other low-end motion capture systems that by means of a simple sensor and using physical algorithms of inverse kinematics are able to transform simple data into a complete motion capture system and animate completely our body, not only in terms of hands, but in terms of the full body. Then we need to define how to represent virtual humans. We want virtual characters to be interactive, to be realistic. So what usually is done is to create a layered model of virtual characters. On the one hand, we have a simple skeleton, which is basically a hierarchy of bones, like it happens in the human body. This skeleton is what is actually animated. This skeleton is driven by motion capture systems. And then we have a polygonal mesh, which is a 3D model able to be deformated by the skeleton motion through a mechanism of skinning. This means that we can rig our 3D mesh across our skeleton, assigning a complex system of weights and other parameters that let this deformable body follow the movements of the skeleton, which again may be driven directly by a motion capture system, and therefore we achieve a completely natural movement and behavior of the digital human body. Sometimes this is enough. For instance, for facial expression, this mechanism is too complex. Then in this case, we commonly use what are called blend shapes, which means that we have pre-made meshes representing emotions, expressions, or even just visemes, which are the visual correspondent of phonemes, elementary units of speech that are reflected into the mouth movement. And then we morph across these blend shapes in order to achieve the maximum possible realism of human animations. Now we have almost all the building bricks for a virtual reality experience. We just miss what is called immersive visualization, so the possibility of render visually all the visual elements and present them to the eye of the user. This can be achieved by means of complex projection-based systems, but more commonly by means of visors. This kind of headsets, typically called head-mounted displays, are now really affordable. Just 10-15 years ago, the cost was simply not affordable for standard users, but now the cost is more or less the same of a video game console. So almost everyone can now have his own or her own virtual reality experiences. So now what we have, everything is needed to create a form of performance involving virtual reality, which we will see in the next video.